All right, lesson 7. We are almost through the basic math and we're close to the finish line and getting ready to actually work through some heftier math chemistry problems. So we're almost to the actual chemistry part. Power property of logarithms. Why do we need this? To solve for an exponential variable. Okay, this is a variable that is located in the exponent of some fancy math that we have gone down through some equations and found. Okay, so this is an example. Solve for x. 2 equals 10x. Here's our law. The logarithm, it's base 10, of a to the power b equals b multiplied by the logarithm, base 10, of a. Okay? So, what is a to the b? Where are we getting a to the b from? All right, well, a to the b is coming from here and here, okay? So this side, log of a to the b, is gonna come from this side, log of a to the b. Well, you see 2. Well, is that a or is that b? What is that? I just see a 2, right? Well, it's not just a 2, right? We've talked about how there's lots of things that are just randomly understood in math, right? An x is not just an x, it's a 1x. A 1 is not just a 1, it's a 1 over 1. And a positive 1 is not just a positive 1. It's a negative 1 times a negative 1 equals a positive 1. There's lots of things that are just inherent, or they expect it to be inherent. They expect you to just know it. And a lot of people just don't know it. So everyone knows that 2 squared, well, hopefully you know it, 2 squared, or 2 to the power of 2 equals 4. Because 2 times 2 is 4, right? So you know that 2 to the power of 2, 2 squared, equals 4. Well, here, there's an understood 1 right there. So it is 2 to the power of 1, all right? Let's scoochy this. So looking at this value now, over on the left, you can see that 2 is gonna be your A. Let's use purple over here. A is gonna be your 2, and B is gonna be 1, okay? All right, so that's on the left-hand side. Let's go to the right-hand side, okay? We've got B multiplied by the log of A, all right? Your A, pretty obvious, is gonna be 10. Let me use red over here. Let's cut this in half. Red over here. Your A is gonna be 10. Your B is gonna be X, okay? So A equals 10. Whoops. B equals X. All right, so now we're gonna fill in for this power property of logarithms law, all right? So, So we've got, hopefully I can fit all this. Log of the quantity A, 2, to the B, 1, equals B here, x times log of the quantity A over here, 10. Okay? Now, just like our previous lesson, we're going to solve an equation for our variable x. All right? So we have something equals x multiplied by something. All right? We want to get x all alone. This is multiplication. To get x all alone, you do the opposite of multiplication. What is that? You divide, right? So you're going to divide both sides by what? By all this excess junk. Log of 10. Okay? Log of 10 divided by log of 10 equals 1. That 1 stays here. It's just understood right in front of the x. Okay? Understood. Then you divide the other side by log of 10. You plug that into your calculator and you'll get a value for x. And it's some sort of exponent like 0.3 something, something, something. Blah, 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 blah. Whatever it is. It's a decimal. Okay, but that is the idea. How you use the power property of logarithms, why you need it to solve for an exponential variable. So a variable inside your exponent. This is the law. Log of the quantity a to the b power equals b multiplied by log of the quantity a. All right, and you're looking over here. There's an understood power of 1 here. A 2 is never just a 2. It's a 2 over 1. And it's a 2 to the power of 1. All right? So your A is 2. Your B is the power of 1. It's understood. Over here, your A is 10. Your B is x. Fill everything in. You solve your equation for your variable x. You get it all alone, and you get some ridiculous decimal. Or if your teacher wants you to leave it how it is over in fractional form, leave it in fractional form, but that's up to the teacher. All right, let's talk about units. A lot of people really struggle with units. They struggle to keep units straight. They struggle to bring all the units up into the numerator, which is, if you don't know this yet, in fractions, numerator is the top of the fraction, and the denominator is the bottom of the fraction. I hope and pray to God you already know that. If you don't, that's the case. So what we're gonna do is kind of have some fun and move units around, work on the powers of units and how they move from top to bottom through the denominator and numerator and blah, 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 blah. All right, so in order to do that, we're going to use the negative exponent rule. Okay, this is a math rule. So what does that mean? Well, what is 1 over s? If we were to take that s and move it from the denominator into the numerator, that s would be s to the power of -1, okay? So, let me get a different color. I'm never gonna keep all these straight. 1 over s equals s to the -1. All right, now, if we know that 1 over s equals s to the -1, what is 1 over the quantity 1 over S. You do this step by step, okay? Just like PEMDAS, please excuse my dear Aunt Sally, right? We just did that a couple lessons ago. You're gonna do your parentheses first, okay? What's inside the parentheses? 1 over S. 1 over S, we just said, is S to the negative 1. So you're gonna get 1 over S to the negative 1. All right, here's the thing. When you pop that S, now back up here, that negative 1 is going to turn into a positive 1. Okay, this is just a rule that you need to get through your mind. Okay, it's not going to, that rule is not going to change. It is what it is, and it's just a property that you have to memorize. It's just like memorizing